Assalamualaikum. Welcome back to Sir K Loves Physics and Chemistry tutorial for high school students. Today's video focuses on two problems involving time dilation, which is a consequence of Einstein's special theory of relativity. So just hang on, watch and learn. Question number 1. Using the formula for time dilation, how long would it take a person traveling at 99% the speed of light to travel to the star Procyon, 10.4 light years away? Question number 2. Dawson and Braden are 20-year-old twins living on Earth in the 25th century. Dawson, who is a space traveler, flies to the star Altair about 17 light years away at a speed equal to 0.90 the speed of light, then returns to the Earth at the same speed. Question is, what are the ages of the twins when they meet again? In question number 1, the speed of the space traveler is 99% the speed of light. The star Procyon is 10.4 light years away, so we can express the time it takes for the space traveler to reach the star Procyon as delta t equal to 10.4 years. Take note, this delta t is relative to an observer here on Earth, the Earth being considered as an inertial frame of reference. The target variable is delta t naught, which is the travel time of the space traveler with respect to him, okay, in the high-speed spaceship. And the formula that relates delta t and delta t naught is given in this equation. All right? This equation is also known as the time dilation formula. All right? And for us to facilitate easy computation, we first substitute and simplify the term in the denominator. All right? This term in the denominator is also called the Lorentz factor. So, we first substitute and simplify, that is, 1 minus b squared over c squared, all right, can be expressed as 1 minus quantity 0.99 the speed of light c, all right, square that and then divided by c squared. That is 1 minus 0.9801 or 0.0199. And since our target variable is delta t naught, we can isolate delta t naught and come up with this working formula. Delta t naught equals delta t multiplied by the square root of 1 minus b squared over c squared. So substituting, we get delta t, which is 10.4 years, multiplied by the square root of the number inside the radical sign, which you already have simplified equal to 0.0199. Alright? So doing our math, we will get 10.4 years multiplied by 0.141. That is the result of getting the square root of 0.0199. And finally, we arrive at the value of delta T naught, alright, equal to 1.47 years. Okay? Again, we stress that this is the time of travel to the star Procyon as observed by the space traveler. And as expected, this is a lot less than delta T of 10.4 years. 10.4 years is what is observed here on Earth. But with respect to the space traveler, it took him only 1.47 years to reach the star Procyon. For our last question, question number 2, we're given the distance of star Altair from the Earth, which is equal to 17 light years. Now, from Braden's perspective, Braden is the twin brother left on Earth. Okay, so from Braden's perspective, his brother Dawson, the space traveler, makes the round trip in a time delta T. All right, delta T being equal to 34 light years times the speed of light c divided by 0.90 the speed of light, which when computed, that will be equal to 38 years. So, again, based on the time dilation equation, where the delta T equal to 38 years is equal to T naught divided by the square root of 1 minus quantity 0.90 squared. And doing your math, we get the value of delta T naught equal to 17 years. Right? So take note, delta T naught is the time of the round trip travel as observed by the space traveler Dawson. So, our answer to the question, therefore, is that when Dawson returns to the Earth, he is, in fact, physically only 37 years old, while his twin brother, Braden, is already 58 years old. So that concludes my lecture on this topic. Till the next episode, mabuhay, mashallah. Thank you very much for watching. Please follow me in my FB page, and please don't forget to subscribe to my YouTube channel.